Hi, Assalamualaikum. My name is Nur Atika Salihah binti Salimi and my matric number is CI240024. Okay, today I will present our project on fuzzy logic-based car parking assistance system. Parking in tight or crowded space can be challenging to limit visibility and human error. Traditional parking system often rely on fixed distance limits and cannot adapt well to different situations. To solve the to solve the to solve this, we use fuzzy logic, which allow the system to make discussion more like human work. It can handle unclear or imprecise data, making it perfect for real world conditions. So fuzzy logic is already used in many smart systems like conditioner, washing machine, and automotive safety features. In our project, we design a system that adjusts brake force based on three input. First, the front distance, near distance, and basic speed. We use triangular membership function, the Mamdani inference model, and contract diffusification to calculate smooth and adaptive braking action. The goal is to make parking easier, safer, and more efficient. Alright, thank you.
Hello, Assalamualaikum, and hi everyone. My name is Muhammad Haziq Raimi bin Makhirul Azhar. I will begin with the system analysis of our fuzzy logic based car parking assistant. The project doesn't use real data. Instead, we simulate typical parking situation using three input variables: front distance, rear distance, and speed. Each input is divided into fuzzy category. For example, front, rear, distance are classified as near, medium, and far. Speed is slow, medium, or fast. The output is brake force on scale 0 to 10, and it's also grouped into fuzzy term, soft, moderate, and hard. The aim is to help driver brake safely based on the sensor input, especially in tight or uncertain biking condition by using human-like decision logic. Okay, now let's move to the system design. The system is developed using MATLAB Fuzzy Logic Toolbox. We use triangular membership function for all input and output value. The system apply a Mamdani inference model, which is suitable for decision making in control system. To get a final output, we use centroid defuzzification, which is find the center of the fuzzy area to calculate the exact brake force. The design include four main steps. Okay, first, fuzzification. Turn number into fuzzy term like fast or near. Second, rule based. Use if then logic example. If front distance is near and speed is fast, then brake force is hard. Third, inference engine. Process our matching rule. And four, defuzzification. Give a final number like 8.5 for the brake force. Okay. The design allow the system to respond smoothly and intelligently, just like a human would then when they're parking. Okay, that's all for me. I will pass to the next presenter, Muhammad Sharifuddin.
Assalamualaikum and hi to Doctor. My name is Muhammad Sharifuddin. Now I will show that uh, demo for our car parking system use fuzzy logic approach. So I will demonstrate the fuzzy logic car parking assistance system developed using MATLAB, online MATLAB. This system help simulate real life parking condition based on three main inputs, which is front distance, rear distance, and also speed. And then for the output is brake force, that indicating how much braking is needed in different parking scenarios. So as you can see, I already opened the MATLAB, by typing the fuzzy in the common window prompt, as you can see like this in this. So they will show like this, and then you can now I will demonstrate how to define input variable. For example, before that I will double click front distance, and then they will show in this loop, and yeah, the front distance I will set between 0 to 100 for the range, with triangular membership functions representing near, medium, far. Same for rear distance is near, medium, far, but for the speed is slow, medium, fast. For the brake is soft, moderate, and high. And then the rear distance range is also same like front distance, which is 0 100. For the speed it is different, which is 0 60, and for the brake force is 0 to 10. And also I will set the parameters is 004, same is 004, but for the speed I will set 0 0 20, and parameters for brake force is 004. And then the output brake force is also defined between 0 and 10, like I tell before this. And they will show on the rule viewer output, which is in the low braking, medium braking, and high braking. As you can see, the triangular graph, the height, moderate, and soft. So next, I go to the rules section and define the fuzzy rules. For example, if front distance is near and height speed is high, then brake force is high. And if rear distance is far and speed is low, then brake force is low. So you can just click close, and then you click edit, and you just click rules, and then they will show you that rules you want to set. Before I tell already is, if front distance is medium and speed is fast, then brake force is high. So I will set 5 rules, and if you want to set, you just click maybe just near. If you want to front distance is start with far, and rear distance is start with medium, and speed is also start with medium. If you already set this, and for the brake force I just forget, and moderate, and you can just add rule, and then the new rule will be add in this part. So if you don't want, you just click delete. So for our system, I just use 5 rules that's already input in this. So for the rules, after you already set the rules, I will show that the output in the two surface, which is surface 3D and also rule viewer view. You just click rules, and they will show two, and you just click rules. In this rule viewer, as you can see that the graph and also the range that I already set before this, 0 100 0 100 0 60 and 0 10. Once the rules are set, I use the rule viewer to simulate the system. You can slide the input value and observe the change in output. For example, setting front distance to 20, so I will put 20, and for the rear distance I will set 60, and for the speed I will set 50, and the result in a height brake force will show value. So you just click, and then you can see front distance 20, rear distance 60, speed 50, and also the brake force is 5. And then you can maybe you can just input any value you like, maybe 40, for example, 50, and also 70. Then the value is will change in the different. Oh, okay, as you can see. like maybe just uh, 60, and then you just click, and then the output will show in the difference. So we move to the second view, which is you can see on also on surface 3D, which is the surface viewer provide a 3D, as you can see from my laptop view. The surface viewer provide a 3D visualization of how two inputs affect the output. This helps us understand how the system behave across a range of inputs. So you can just maybe if you want to start with front distance and speed, they will show on that graph. So for my conclusion of this MATLAB and relate to our system, which is car parking system, this fuzzy logic system provide flexible and intelligent methods to assist drivers during parking by analyzing distance and speed to determine the proper brake force. And also MATLAB's fuzzy logic toolbox simplifies the design, training, and simulation of such smart system. I think that's all for me to demo our system. I hope doctor understand. I hope and I hope doctor will enjoy of my presentation. So thank you. That's all for me.
Okay, Assalamualaikum and hi. My name is Muhammad Jarib Sofi bin Muhammad Sabri. My metric number is CI240043. Okay, I will present about result and test case. System design. The model consists of fuzzy inference system, or we know as FIS, with three input variable, which is front distance, rear distance, and speed. And one more for output is brake force. Each input and output variable is represented using triangular membership function to define fuzzy linguistic term. For input, we choose three distance, which is front distance, rear distance, and speed. For front distance, it has near, medium, and far. For rear distance, it has near, medium, far. For speed, we have slow, medium, fast. For the output, we have brake force, which is soft, moderate, and also high. Okay. This is picture for front distance graph on MATLAB. And the second one is rear distance graph on MATLAB. Okay. For second slide, we have speed graph on MATLAB. For brake force graph on MATLAB, and surface view loops on MATLAB, and the last one is rule viewer loops on MATLAB. Okay, that's all.
Assalamualaikum. My name is Ayu Delila, CI240040. I will be presenting the conclusion of this project. In conclusion, the fuzzy logic-based car parking assistance system was successfully designed and simulated by using MATLAB. By utilizing front distance, rear distance, and speed as input variables, the system was able to determine an appropriate brake force output that adapts to different parking situations. The simulation result demonstrate that the system provides smooth, safe, and human-like braking response, especially in tight or complex space. Overall, the fuzzy logic approach proved effective in handling uncertain and dynamic parking conditions, making it a suitable solution for enhancing parking safety and precision. That's all from our group. Thank you.